Hello, I'm Liam with Texas Instruments RF Power Group. I'm here to talk to you today about our SuPA technology. Our family of DC-DC converters for RF PAs, 2G, 3G, and 4G LTE. Over to the left, I have a block diagram on the monitor here. Shows you right where the switcher sits in, the SuPA fits into the transmitter system. The power amplifier for a typical smartphone, and then the battery, the DC-DC converter, provides the output voltage here. Lithium-ion battery typically will run from 4.2 down to about 3.4 when it's fully discharged. All that extra headroom will go into wasted heat because you have to design the PA for the worst case conditions down at the low voltage. By switching that down to the lower voltage, we can save a lot of heat and also reduce the current consumption of the phone. As you back off power, because you're not going to be transmitting full power all the time, when you move away from the base station, your handset transmits a little less power. Then you can back off the voltage and realize some really significant power consumption improvements. One of the things you have to be concerned with, though, putting this switcher right next to the PA, that, any noise can get right outside the antenna. And as an RF engineer, we want to make sure that that is very clean. Texas Instruments has done a lot of IP development to make sure that this is a very low noise converter that doesn't corrupt the output signal. I have a demo set up today that shows some measurements of some of the key parameters we look for when we're characterizing these power amplifiers with the DC-DC converter. On this evaluation board here, I have the LM3242 DC-DC converter, which is for 3G, 4G PAs. You can also look on the website. We also have a video for the 3243, which is the 2G, 3G, 4G. And also, so this 42 drives a power amplifier here, of which we get the input source from a signal generator, and then on the output it's connected to a signal analyzer. We have some power supplies which show the voltage as well as the current consumption. So if we set this to max power, you can see about 27.5 dBm for the wanted channel here, and the adjacent channel for the wideband CDMA is about 3.84 megahertz offset. We don't want to have a lot of noise here because somebody else is using that channel, your neighbor or somebody, and get corrupted. They drop a call, they're not very happy. You can see as I reduce the voltage that the adjacent channel power, or the ACLR, goes up, and then it doesn't meet our minimum margin requirements for key performance. But then if you back off the power a couple dB, now you have plenty of linearity, and you're back below the specs of minus 39 or minus 40 dBc. So as you reduce the output power and your handset is closer to the base station, you can reduce the voltage, and that provides a very significant current consumption benefit. So here we reduce the voltage, goes down to about 2.5 volts, and the current consumption is now less than 250 milliamps. So you can see from this demo, there's a lot of current consumption benefits that you can get from using the DC-DC in their transmitter. Really increases your talk time, and you don't have to charge your phone so often. Everybody likes that. So for more information, go to ti.com/rfpower. Thank you.